Hello, welcome to my poster. So I will be talking about the pH and salt-dependent phase composition measurements of two-phase oppositely charged polyelectrolytes. So for polyelectrolytes, we know that it can be found in our body in the DNA, RNA, and proteins. It's very important. And when we put two oppositely charged polyelectrolytes together in a salt solution, they will went through an associate phase separation where a dense phase at the bottom we call it coercive phase, dense in polymer, will form, and on top of that there's a phase we call supernatant, where there's less polymer in it. And then the coercivate phase actually lead to a lot of applications, like the water adhesive, underwater adhesive, and biomaterials drug delivery. Even though there's a lot of applications, the theory behind this was actually not really quantitative. So recently, there's many theories that pop up trying to modify the classic model. But before any of the models can be of any value to predict the phase behavior, um, they need experimental validation to see whether their predictions was accurate or not. So I was there to develop a combination of analytical characterizations to quantify each composition of the each phases. So for the two phases, we need to measure two different polymers, and there are four variables in the two phases and also the salt in both phases, as well as water. So for the polymer concentration, I'm actually using proton NMR and carbon NMR. So there are two polyelectrolyte systems I'm choosing. One is a strong pair, another is a weaker pair. The strong pair is for me to test my method, and the weaker one is for me to modify some of my methods so that it can work well. So the stronger system, I'll just say PSS and PNMAC here. I'm using the TGA to guess the total of the polymer and salt weight percent, and from there I'm using the conductivity to try to quantify the salt concentration. And as for each individual polymer, I'm using proton NMR, quantitative NMR, to get a linear calibration curve so that we can have the accurate result. And then we want to move this combination of methods to the weaker one, which is PA, the PSS. Here, we're changing the conductivity methods to the salt concentration titration and carbon NMR instead of whole proton NMR to test it, and that all worked well.